hey, wearable world's tomorrow, and I thought I'd come and talk to somebody who actually knows something about the Internet of Things. Because we hear all these terms like Internet of Things, and what does that all mean?
It's a very malleable term. It's a broad church.
First of all, who are you?
Yeah, I'm Brian Kelly. I'm CTO of Golgi and co-founder.
Very cool.
And we're a cloud service for IoT developers.
Yeah. So when people say IoT, what are they talking about?
As I say, it's a broad church that encompasses everything. But what it tends to mean is things that either didn't exist before, or they did exist and weren't connected to the internet, and are now being wired up and controlled or interacted with in some way, normally via mobile phones.
Like the Nest thermostat and the Hue lights and the drop
exactly.
cams. That's Perfectly. The consumer side of that.
Yeah, they'd be the poster children for that.
Now, Union Pacific has a railway right outside your door, so we might hear the train go by. They have sensors on railways.
They certainly do, and they've been doing this IoT thing. Maybe not the I part of it, but certainly they have a big network of things for a long time. As has industry at large. Oil and gas have been doing it for a very long time as well.
So tell me why we need new kinds of software that hooks these things up. Why doesn't the old client server or the old databases that used to work, that Oracle built and Silicon Valley has lots of, why doesn't that stuff work anymore? Well, why doesn't Rackspace or the Amazon clouds work anymore? Why do we need you guys?
Some of that stuff does work. So the data analysis, the big data side of it, that all still kind of does work once the data can get there. But getting the data there can be a little bit tricky. And then one of the bigger challenges then is interacting with these devices from a mobile device. Yeah. That mobile device, normally when you're using your mobile device, you're talking to a server that's up in the cloud that's accessible from almost anywhere. If you want to interact with a device that's in your home or in your enterprise, that can be difficult to connect to. That's normally a very, quite rightly, a kind of a secured location that you can't just willy-nilly make an inbound connection to some device that's in there. Yeah. So those connectivity scenarios, up until now, not really encountered in the day-to-day by mobile app developers. In order to solve those, you need something in the middle that both the embedded device can connect out to and the mobile application connect out to. So kind of like a dial-out architecture, if you will.
So write up some devices here and show me what your stuff will do and how it will wake up different devices.
So if you have a device of some sort, an IoT device in here in your home environment, and it's connected to your Wi-Fi router, which is connected out past your wall, out here into the cloud in some way. So this device, for simplicity, we'll just say it has Wi-Fi connectivity here. Okay. Now, it's able to make connections in this direction. And your router here, your router is set up, we'll have a firewall.
You're Irish, right?
Yes, okay, your router. Your router here, it will be set up, it will be firewalled to only allow connections out, so there's no connection could be made into that device. And indeed, the IP address typically of these devices in here will be private IP addresses that just aren't routable from the outside world. So getting to it is difficult. Now, if you take a couple of those examples, the Nests of this world, the drop cams of this world, if you're out here on your mobile device,
and there's that train.
If you're out here on your mobile device and you want to interact with that IoT device in there, you cannot make, if you're out in the big bad world, out on 3G or LTE, this device cannot make a direct connection with that device in there. Okay. There's just too many firewalls in place. And indeed, even here, even if you're on the other side of Mr. Telco here, he will behave much like this here, probably giving you a private IP address, even on LTE, so that you're not directly accessible either. So these things, these two worlds can't interact directly.
Got it.
So you're going to need some kind of third-party kind of orchestrator up here, which will facilitate at least the illusion of them being able to talk directly to each other.
Okay.
So if you want to solve...
Now, how did the Nest do it? Did they wrote it themselves?
They wrote it themselves, yes, I would imagine. So anybody who's doing this kind of interaction needs to solve this problem.
Yeah.
Now it's understandable as a problem. There's no there's no dark arts in there.
There's even companies that do it hardware-wise, that they build it into the hardware firmware so that it can talk out to some sort of cloud. Outside,
yeah. But again, it is something you'll have to put together. You can't do it without getting somebody involved up here to kind of be a kind of a mediator between those two, because the kind of the firewalled internet has been set up to allow these outbound connections. Typically for HTTP clients down here to talk to HTTP servers up there, to make a TCP connection out and get a result back, but not to make a TCP connection out from here right back into here.
Got it.
And for very good reasons, because it's not just this that would try and do that. It is all sorts of bad actors out there who would try and do the same thing.
Yep.
So you need something in here in the middle. Some of the other problems that you have then is, while you can conceptually understand what might happen there, your IoT device might have a persistent connection up to this this cloud up here, and anytime the mobile device wants to interact with it, it talks up to this cloud here, and that will route the data down to your device down here.
Got it.
But in the other direction, where something might want to be initiated from the mobile device, from the embedded device itself, it's a little bit more difficult. You do not want your mobile device to have a persistent connection to the cloud. Not good for battery. And if you have 5 different applications here trying to do that, 5 different connections, that's 5 times worse for battery. So the typical way of getting mobile devices kind of initiating interactions with them is using push of some sort. So what you really want to do here is have an ad hoc connection that's just used as necessary. And if something comes from the embedded device up to the cloud and needs to get down to this device down here, you should use push to wake up the device, get it to connect up in the way that it's allowed to do, and then send your data down to it.
Got it. Sounds like a lot of code to write.
Yes. And that's just, that's, as I have said, that's table stakes. That just gets you to the starting line of then you can start writing your functions and your features on your embedded device and your mobile application, and doing the bit that you're going to be recognized for, rather than the wonderful plumbing that goes on under the hood.
Yeah, because Dropcam doesn't.
No, you don't go, wow, that's a good use of push. You go, oh, there's somebody at my door, right?
Yeah.
So yeah, you won't. That you're not going to be loaded for doing all of this. Yet you must have this in place in some way. And if you're resource constrained, as everybody is, then you got to pick your battles. Yeah. And if you can find somebody who can do this for you, to allow you to focus on your features and functionality down here, where you're going to be recognized both on your embedded device.
And that's where you guys come in, right?
That is where we come in.
And how do you charge for that, man? And you're on top of an existing cloud, so you're hosted on an Amazon or something like that, or Rackspace.
So you can put this together, you can get this connectivity working without you as a solution having to deploy anything in the cloud. So it's an as a service offering. The fundamental metric is a kind of number of endpoints being a mobile application or embedded device. It's a lovely generous free tier, so you can test and prototype to your heart's content, and then when you go into production, it kind of scales up non-linearly, obviously getting more efficient as it goes up.
Well, now you know why I'm here. So I'm interested in things that are in the middle.
Yes.
At Rackspace, that's what we care about, right?
Of course, yeah.
And we care about supporting this whole system for developers. Do you have competitors, or what's the competitive landscape?
So there's competitors at various bits of this. Nobody that we've necessarily come across yet is doing the whole 9 yards. So there are people who are doing the connectivity. So they can get you the connectivity back and forth between the devices. But we're more than the connectivity. We allow you to kind of even take a little step back from just the connectivity and define the sorts of data you want to exchange, your actual interactions, and we generate code for the endpoints, both the embedded device and the mobile devices, both on Android, iOS, and in a web application.
Very cool. Thank you so much. We're out of time.
Okay.
It's been 10 minutes.
Thank you.
And this is where we get it, Golgi. Right?